I would like to say good morning to everyone, and now it's time to kick off this week's consumer webinar. A really warm welcome to everyone. I'm really glad to have you all here today. And I am Elizabeth Whitefield from Business Development within EY Consumer Sector. And we started this series of webinar during spring, then to follow the development of consumer behaviors due to the pandemic, which we also will continue to do in coming sessions here during fall, to help us navigate in these somewhat unpredictable times. And also to support future developments, we present various solutions of relevance within different areas. So today we are joined by Frank Kody from EY Advanced Analytics team, who will present and discuss how to solve data quality issues by leveraging AI and machine learning. But just handing over to our speaker of today, since we only have these 30 effective minutes together this morning, there's not much time for Q&A. So please write any questions in the chat, and we'll address these if we have the time, or we'll get back afterwards to everyone. So please, Frank, the stage is yours.
Great. Thank you very much. I'm going to minimize this box down here. So thanks for having me today. I'm going to talk about a topic that I'm quite interested in because it merges two areas that I've spent some portion of my career focused on. One is data management and data quality, and how much of a challenge that is in an ever-growing battle. And then it also merges the second topic that I'm quite interested in, which is advanced analytics and associated machine learning and AI technologies. So what we'll cover today is I'm going to talk about why data quality is important. I'm guessing I don't need to remind everyone of that, but I think it's good to establish a common foundation. Secondly, I'll discuss the traditional approach that most actors are taking when it comes to addressing data quality issues. And then I will talk about EY's AI-enabled or powered approach. Thirdly, I'll provide a bit of a demonstration of a tool that EY has developed that showcases how this AI-based approach sort of can look in the end as an end product that demonstrates a lot of the technologies used. And then finally, I will discuss a bit what your data quality future could look like within your enterprise if you leverage some of these technologies, and how it can really sort of kickstart regenerate efforts to address data quality. So I believe personally that addressing data quality problems is as important as ever. And I think there are many reasons for that. There's not just one, but there's three reasons that I want to highlight here. One of those is that there's the growth of data within companies. I think that is something we've been established and seeing over the past several years, that the amount of data within a company and the amount of data that a company collects and relies on is growing at an exponential rate and will continue to do so going forward. So this becomes a very important aspect because data quality problems have always existed and will always exist going forward, potentially. And then as the amount of data and systems that your company has grows, those problems will grow with it unless you address them. The next point that I believe is important to highlight is how interconnected all of your systems are now in terms of how much data is sent back and forth and is flowing throughout the enterprise. I think systems are talking to each other more and more now, and especially with the advent of new enterprise architecture frameworks that focus more on APIs and data sharing and rely on this as a fabric of how your system works. When data is sent that is bad, that is sent throughout that system, it could have a profound effect throughout many systems. And then the third point I would argue is as your organization becomes more data-driven, it only emphasizes why data quality needs to be addressed before you need to make that data-driven decision, because there's nothing that erodes trust in data more than looking at a graph or a number and not agreeing with what is there and seeing blatant errors as well. So all of these three things I view as important factors of why you should focus on data quality now, again, and then with the goal of achieving trust in data. And not only is data quality a growing problem, and not only has it been a problem, it also has a substantial impact and will continue to have a substantial impact on your organization. There is significant financial loss associated with data quality problems. IBM a few years ago estimated that $3 trillion in the United States was lost due to data quality issues, and this could vary, from the source of what actually caused that, from customer data being incorrect to supply chains freezing and breaking due to bad data, or selling products at incorrect prices, or understocking, overstocking, underordering, overordering. I mean, there could be so many reasons why, but they've tried to sum that up into a number. At the same time, recently Gartner has said it costs companies annually $15 million per year, and that's a significant chunk of change in my book. The second point that I see as a bad impact of poor data quality is productivity loss. Not only in the situations where bad data impacts how your employees carry out their processes with fulfilling orders, fulfilling logistics duties, maintaining standard daily operations, where that could have a negative impact. It also impacts your analysts as well in a negative way. Forrester came out with a study a couple of years ago that said 40% of analysts spend about a third of their time validating data and fixing data quality issues. That is a lot of time, in my book, to have your sort of analysts who are focused on generating insights from data to be spending on validating and fixing data quality issues before they can present those insights and trust them. And all of that leads to a low overall trust in data, which, as I mentioned before, is not an ideal situation. And it's important to know that when we talk about the things that are causing data quality to be more important now, and we talk about the substantial impact from that, it's important to realize that these data quality issues are not siloed. They're not only stuck in master data. They're not only stuck in your inventory systems or warehouse management systems. Those are typically not the sources of it. They're not only battles that analytics teams and BI teams need to face on a daily basis. They are pretty pervasive throughout all systems, because there are so many, there's so much room for error. There's so much room for data quality issues to grow and to be created, because even if you have data that's perfectly imported into as product master data or customer master data, as this master data is used and lives and breathes throughout customer service systems or sales systems or lead follow-up or supplier negotiations, and as it moves all the way through your ERPs down into reporting and analytics, warehouses and cubes and data lakes, a lot of data is going through transformations. It's moving from point A to point B, and that increases the risk of error and increases the reality that you face, where data can turn into something when it moves from point A to point B after it undergoes a transformation. So I believe there are many places, and I've seen data quality issues in all of these places, having worked with a lot of data and data sets covering these topics. And this is not encompassing. It also covers financial data. It covers other information as well, legal, contract, all of these types of information, not just what I have shown here, but I wanted to provide a bit of a sample. So traditionally, you've had data governance organizations and master data management teams and analytics teams focused on managing data quality issues. However, the process that I have seen a lot of companies take, and maybe not all companies are taking this, but I've seen a majority of companies taking this approach, the process is full of pain points. So there's a simple 3-step way to view data quality and how people have been managing it so far. One is the process of identifying the data quality issues. The second step is, coming up with some type of some type of remediated value. What could I change this data quality error to? And then finally, the team has to, recommend what our best action is. Do I replace the value? Do I not fix the data quality record? Do I do something else to change it? And this is a manual process. I've spent, quite a few projects in my junior consultancy career on this traditional flow here, and there's a lot of pain. I think when it comes to identifying data quality issues, this is a process that requires a lot of legwork, a lot of manual work. It requires, assessing each data set uniquely, meeting all of the data experts and data owners about that data set, anyone who's interacted with it, having all of these sort of manual investigations to know what are the rules that we should come up with that qualifies that, this product master data record is of high quality and this one is not. And this column should be, full of these types of values and these should not. There's a long list of data quality rules that typically comes out of it, and they can be a couple hundred long, which is quite a bit of manual hard coding that needs to be done. And the challenge here is that typically these rules you come up with to identify data quality issues in a particular data set only cover a known data quality issues. Therefore, you're running the risk already of that becoming outdated fast, because how many times have your data governance organizations said, I've never faced this data quality issue before, or I've never seen that data quality issue before? That's because these things come up on an unknown basis. If we knew them all, then we wouldn't have this issue to begin with. So these rules that are manually identified and created become outdated fast. And in addition to that, when you have these SQL-based rules or Python-based hard-coded rules, they typically don't do a good job at automatically recommending or remediating the data quality issue itself. You can create basic rules like imputing a new value to cover a missing value in a column. That is a very simple one to remediate, but those rules typically lack, significant precision to handle more complex problems. And then in addition to that, when you recommend what your next step is to address it, all of those alerts that you've been given of these 50 data quality issues have been alerted today from your traditional engine. There's no typically triage between how should I prioritize between these, how should I have my team of two, prioritize which data quality issues are important and which ones are not and don't need to be changed. So you have a lot of these like critical data quality focused resources spending a significant amount of their time tackling false alerts, following a highly manual process to get the root cause investigation done to what they should replace the value as. So lots of challenges. So we have a team based in EY in Europe who's very like financial services and banking focused, and specifically on fraud. So this team has been, using machine learning and AI technologies, quite a bit throughout the course of the past several years to fight banking fraud, to fight fraud in the financial sector. So they, thought, since they're typically leaders when it comes to employing these data and analytics-based technologies, they have been historically financial service companies and banking companies have been leading the charge to using and adopting data and AI-based solutions. So they thought, how could I, leverage the techniques that I'm, using to fight fraud within banking to also fight like fraud within data quality, because that's really what a data quality issue is in the end. It is a fraudulent data record living in your databases, living in your ERPs that don't belong there. They're acting badly. They're doing something that's incorrect. They look different than everyone else. So it's a very similar type of problem. So what they've done is they've applied machine learning and AI techniques that they use to fight fraud in all of the right places along this same value chain for fighting data quality issues. So I'll break that down of how they do that. When it comes to identification, they are leveraging some anomaly detection methods that are based on unsupervised machine learning. They're saying, find a data quality record or find a data record that looks different than everyone else, that is an outlier, that looks like they don't belong. They use supervised machine learning methods to say, here are an example of 1,000 records that I trust, that this is what all of the records should look like. Have a machine learn those patterns, learn what that looks like, and then go attack the rest of the data set to say, find the records that don't look like this. They also leverage natural language processing techniques that say, for my unstructured fields, my free text fields, here is typically what those free text fields say. Here's what they shouldn't say. Go find and use your methods, Mr. or Mrs. AI, and find the records that don't look similar to everyone else. And then they embed an active learning component into it as well to identify data quality issues that say, okay, I found these 100 data quality problems. Please mark whether I was correct or not correct. Check my work. And then after you check my work, I'm going to learn and not make those same mistakes again. And that really, provides significant advantage. For example, it not only detects the known issues that I discussed before, where your data experts could provide that insight, but it also does a great job at finding unknown issues, because these unknown issues are typically this outlier type of behavior. And then it's not only really good at applying AI and machine learning technologies to identify data quality issues, but it also, this approach uses those same methods, a supervised machine learning method, to recommend how should I fix that field. And I'll demonstrate that in this demo next, where you can see that based on the data quality error that occurs, use machine learning to automatically recommend to like, what should I do? How should I fix it? And then finally, when it comes to recommending how to fix it, so you might recommend a value to take, but what route should I take after that? Do I automatically make a correction to my data set? Do I send it to a human to review with the recommended value? Or do I have a manual review by a human, as was in the traditional method? You can use machine learning to also aid in that process. And then you also can use RPA as well to automate that process, to support event triage and indicate what the next best actions are. So lots of cool techniques from banking applied to solve a data quality problem in banking that we see as a significant potential for consumer-based companies to focus on leveraging those same techniques to solve data quality issues in their systems. So now we're going to look at what a potential end solution could look like from following this approach. I'm going to show you a demonstration tool that is going to identify data quality issues with these techniques I just described. It's going to suggest and remediate those problems with a replacement value automatically. And I'm going to show you a module of how it actually leverages active learning to make itself smarter going forward. So let me jump into this here. So I'm going to show you those 3 steps. So the first step is going to be, how does this method identify data quality issues? So what we're looking at is a transaction data set, like, for example, a point of sales data set, where you have a transaction ID, you have some type of country that it occurred in, you have some other fields and flags and details and prices and so forth that describe your point of sales data sets. This is not actually a point of sales data set, but it is essentially very close to one from a data perspective. So you can see that there's some data quality issues already, like missing values. If you look at the sales margin, you have negative values, not a good thing, probably wrong. So you have problems already that you can visually identify within the data set. So you can imagine that a simple data quality engine can actually identify those issues already, and with your basic rules would be able to identify them. However, they probably won't be able to identify all of the issues and all of the rules. So what I'm showing you here is essentially a visual representation of how a data quality AI-based approach will find issues within your data set. So there are 4 types of data sets highlighted here. One is missing values, which we talked about, which is quite straightforward. The next is duplicate values, and this is quite interesting because all this record looks pretty similar, but there is some differences, and I'll describe that next. It also identifies out of range values. So my price here looks out of range according to some statistical method. And then there is another data quality issue that is, it's called inconsistent data, and I'm going to describe a bit of that as well. So if I look at my inconsistency data set, what it's pretty much saying is that you're using a machine learning model to look at these 2 values and say, according to all of the other data records that don't look like this, all of its data peers, all of its data friends, this record has 2 columns here that is standing out from everyone else. It has an anomaly score above an accepted threshold. So what this is actually recommending you do is consider manual remediation, because there are multiple columns that are incorrect, but there is a possibility for automatic remediation as well. So quite interesting that it's able to find that, because all of these values sort of look normal and look similar. If we look at this duplicate record example, this is saying is that you have duplicate records that not only have values that are duplicate, but then in the comment field over here, you have a very high vector similarity. And the reason for that is, if you look very closely, your traditional data quality rules may not have captured this, because there's only one extra letter in this comment field compared to the other one. So then a traditional method probably would not have identified that as a duplicate record. You have some outlier-based detections as well. That is quite interesting. That is just more like taking standard deviation of its data friends. So it clusters using machine learning all of the data records that it should be friends with or close with. And then it says, for these columns, find the standard deviations away from that. So quite interesting as well. So these are not the only data quality issues that it can identify. When you carry out a project with this, you identify the data problems, the types of data problems you want to find. Do you want to find outliers? Do you want to find double entries? Like what types of problems you have, and then it goes and does its searches, and then the machine learning models come up with the rules themselves. So I'm going to show you now how the model actually also remediates these problems. So what I'm doing is I'm saying I want this machine learning model to automatically fix or remediate all of my error types. And I want to take a very sort of like high level of error, into my machine learning model. So fix everything is pretty much what I'm telling it. So what it essentially does at this point is it takes these values that are missing, for example, and automatically recommends, based on a supervised machine learning model, what should the replacement value be. This is just a recommendation. It doesn't necessarily say that automatically needs to save it or not. And as you can see, it's sort of all of the errors that you have in here, it is fixing for you automatically. You need to train, machine learning models to do this, but it is quite powerful when you have this in place. So I think this is a quite interesting sort of aspect, that how I've shown that how machine learning can be used to identify data quality issues and how it can be used to remediate them. So the last component I will show you before jumping back to the presentation is, how does this model actually get better over time? Because you can retrain machine learning models, but it's also important to just be able to give it feedback, feedback of, hey, you did a good job today, or you did a bad job today. So where this is a demonstration module of how you can build in a feedback loop, where what you do is you can have in your end product and solution, you can have all of the data quality issues that it found, and then you can give feedback about, was that a correct error? Was that not a correct error? And so forth, and like tagging and labeling every record that you want. And it can go through and do all this manually, which is so you have your sort of data teams doing this, which could be a fun exercise for them to analyze, and then submit those projections. And then after you submit them, you're able to track over time using machine learning sort of like performance metrics or KPIs for the machine learning model itself. So you're not only fixing and recommending what to do next, you have KPIs about how well the model is performing. You're able to sort of check and see that it's doing a better job now after you've added this human feedback loop in here. So again, this is meant to demonstrate how this actually could look in the future. And this was covering a transaction data set. This is not only based for transaction data. We've also run this on article master data as well, and other master data type solutions. So we're looking at like a product article data set here within one product category, and I'm going to show you sort of into the brain of the outlier detection module a bit on how that works. So if you view all of these red dots as separate articles within your outlier data set, or within your like category data set, like crackers, or this is actually wine specifically, you can see that the machine learning model has grouped based on a few dimensions here most of those articles together and says these all look similar according to these attributes in the data model. However, you do have a group of 2 outliers as well. So it's able to like mathematically compute that those outliers do not belong there. And then after further investigation, we have seen that that is due to shelf life information being incorrect compared to the rest of this data set. So this can also cover transaction-based data sets or master data-based data sets as well. These techniques work for. So realistically, what does the future of your data quality management look like at your company if you have this AI-based process capability? I mean, we've sort of hypothesized that you can have this new sort of intelligent data quality unit, the central data quality intelligence unit that is responsible for data quality within your enterprise, that's responsible for taking this data quality, AI-based data quality platform and going to each prioritized data set or system, training these models for it, deploying these models close to that data set, and then processing back and sending back the results to a common platform where they're able to centrally, as an intelligence unit, identify which of my sort of prioritized systems has data quality problems. How is my machine learning model doing to fix those? They're also responsible for maintaining the operations of it, for also addressing and fixing those data quality issues if needed and routing them to the right person that the machine learning models recommend. And they also are the ones who are supporting this active learning component. So this unit is made up of data scientists, data engineers, but also data analysts who are focused on being data SMEs. Quite an interesting future. I think we have a couple minutes left, so I just want to discuss, where has this been done before? As I discussed prior, this is a leading practice that's followed by banks at the moment. So our credentials within EY are very bank focused. We've done some small projects for non-banking companies like automotive and retail companies, but our major wins and successes have been focused on banks, where you see significant reduction of false positives and significant sort of improvements to how these companies operate in with their data quality identification. So I think we have 2 minutes left. I wanted to thank everyone for their time. And as I said, my name is Frank Kody. I'm a member of our consulting practice and our data and analytics team in Sweden. If you have any questions or want to discuss further, because I'm quite interested and passionate about this topic, I'd be happy to discuss more about how this could be interesting for you, how these models work, how we run projects to set up these data intelligence units and set up these machine learning AI-based data quality platforms. So thank you. That's it for me. So if Elizabeth, you have any final words?
No, thank you. Thank you, Frank, very much for this very interesting presentation. Extremely relevant and very well presented. And as you said, I just want to emphasize that please do get back to us. We're very happy to continue these discussions. And also, I hope to meet all of you again in 2 weeks when we'll talk more about the consumer trends and findings from our Global Future Consumer Index here in this webinar series. So please don't miss that. And please get back to us with any questions and comments on today's topic. Thank you very much and have a great week, everyone.